So in this video we are going to look at some exam questions about the alkali metals and the halogens, and I will walk through them and tell you how I would answer those questions. So we are starting with group 1, the alkali metals. Potassium reacts with water. In a class demonstration, a teacher drops a piece of potassium onto water. Then the first question here is, the teacher ties back her hair and wears a laboratory coat and goggles. Suggest one other safety precaution that the teacher should take. I would say definitely here what the teacher needs to do is there needs to be a safety screen between the students and the demonstration. Also, the teacher needs to make sure that the students keep their distance to this experiment. So these would be two possible answers for this question. What we could also say is that the teacher should only use a small piece of potassium. That would also be a possible answer. Then the next question, it says, describe what you see when potassium is added to water. The most memorable observation we can normally make here is that there is a lilac or purple flame because the potassium starts burning, and also we can see effervescence. Effervescence is kind of the sciencey word for gas bubbles or fizzing. So we can see effervescence, and that means that we see gas bubbles or fizzing. And some other things that you could write here is, for example, you could say that the potassium floats on the water. You could also say that the amount of the potassium gets less over the time of the reaction, that the potassium disappears. Then the next question, we have group 7, the halogens, and it says the elements fluorine, chlorine, bromine and iodine are all in group 7 of the periodic table. State the name given to the elements in group 7. Now the name for the group 7 elements is halogens. That's the answer here. And then it says give the symbol for an atom of bromine. So basically here they want to know the symbol for bromine, which is Br. We need to be careful here. It really needs to be a capital and a lowercase letter. If you write both in capital or both in lowercase, you will not get the mark. So we need to be really careful here that the B is capital and the R lowercase. Then question B, the table shows the states and colors of 3 of these elements at room temperature. The information for chlorine is missing. So we have the table and we have 4 elements of the halogens, fluorine, chlorine, bromine and iodine. State at room temperature tells us that fluorine is a gas, chlorine is missing, bromine is a liquid and iodine is solid. And for the color tells us that fluorine is pale yellow, chlorine is missing, and bromine is dark red and iodine gray. So now we need to fill in the information for chlorine, and we do that in the line here. So either you will know what the color and the state at room temperature are for chlorine. If you don't know, you can kind of use the trend that you see here. So you can see that we go from gas to liquid to solid. So that tells you that chlorine is probably also a gas or a liquid, and chlorine is a gas. And we can see the trend for the color, that they kind of get darker. So we have pale yellow, and then we have dark red and gray, and here also again chlorine is kind of in between, and chlorine has kind of a yellow green color. Okay, now we're going to go on to the 6 marker. Okay, I'm going to read the question again. When chlorine is added to a solution of potassium bromide, a color change is seen. When chlorine is added to a solution of potassium fluoride, no color change is seen. Explain how these observations provide evidence for the order of reactivity of bromine, chlorine, or fluorine. So this question is about the reactivity of the halogens, but we can just start without knowing much about the reactivity, just kind of draw conclusions from what is said here. So it says when chlorine is added to a solution of potassium bromide, a color change is seen. So this is quite important, so I'm going to underline this. So a color change is seen. If we see a color change, that means there's a reaction happening. Okay, so the first bullet point we can write down here is that color change shows or indicates that there's a reaction. So color change shows reaction is happening. Okay, so if there's a reaction happening in the first bit, that means that chlorine is displacing bromine from potassium bromide. So the next bullet point can just be chlorine displaces bromine. Now for the third mark now we have to say why this happens. Why does chlorine displace bromine? And the reason is chlorine is more reactive. So we can just write because chlorine is more reactive. So it's higher up in the group, and for the halogens that means it's higher up, it's more reactive. Then we look at the second sentence where it says when chlorine is added to a solution of potassium fluoride, no color change is seen. So here the big difference, no color change. Okay, and color change shows that there's a reaction, so no color change means there's no reaction, so no color change. So no color change shows there's no reaction. And this means that in this case the chlorine is not displacing the fluorine. So chlorine does not, write the bigger, displace fluorine. And now we just need to finish by saying why that is. Why does chlorine not displace the fluorine? And the reason is that chlorine is less reactive than fluorine. Fluorine is more reactive. So we just finish by writing because chlorine is less reactive than fluorine. Because fluorine is higher up in the group, that means fluorine is more reactive, and chlorine is less reactive because it's further down. And that is all you have to write for the 6 marks.